Good morning, my dear students. Today we discuss the concepts of circles of part 3. In this part, we discuss 7 points. First one, chord of contact. Second one, pole and polar. Third one, pole of your line. Fourth one, conjugate points. Fifth, conjugate line. Sixth, inverse points. Seventh, length of the chord having midpoint x1, y1 is 2 root mod s11. Now come to the point, first one, chord of contact. If you take the point P x1, y1 is an external point of the circle, we can draw two tangents to that circle. The line joining the chord of contact, is called chord of contact. The line joining the point of contact is called chord of contact. Equation of the chord of contact is S1 equal to 0. P x1 y1. Equation of the chord of contact is S1 equal to 0. If S is x square plus y square plus 2gx plus 2f5 plus c equal to 0, then S1 is xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. You can easily prove that one. S1 equal to 0. Second one, pole and polar. Pole and polar. P x1 y1 is any point, either internal or external. Draw a chord passing through P. It cuts at A, B. Draw tangents at A and B. These 2 points, these 2 lines intersect at one point P1. Next, draw another line to cut the circle at the points C and D. Now, draw tangents at the intersection points C and D. These 2 intersect at P2. The line joining P1 and P2, is called the polar of P, polar of the point P x1 y1. That equation is S1 equal to 0. Once again, equation S1 equal to 0. There is a definition of polar of a point P x1 y1. The locus of the, listen carefully, the locus of the point of intersection of the tangents drawn at the extremities of the chord passing through the point is called the polar of the point. That equation is S1 equal to 0. This point P is called pole of this line. Pole of this line. Here in the first point, chord of contact exists only for external points, whereas polar exists any point except one point, that is center of the circle. Why polar does not exist center? By definition, you can draw a chord passing through C, that is a diameter. If you draw tangent at the ends of diameter, these 2 are parallel to the parallel lines. These 2 are parallel. These do not intersect, so we can't find the locus of point of intersection of the tangents. That's why polar does not exist to the center. So polar will be exist for any point, either external or internal. If polar is external, if the polar point is external, then polar cut the circle. If the point is inside, polar outside the circle. If the point lie on the circle, polar become a tangent. Equation of the polar is S1 equal to 0. If the point is lie on the circle, the chord of contact coincide with the tangent. Pole of a line, third point. If the line is given, how to find the pole of the line with respect to a circle? Let us take Lx plus My plus N equal to 0 is a line and the circle x square plus y square equal to r square. Find the pole of the line Lx plus My plus N equal to 0 with respect to this circle, that is minus r square L by N minus r square M by N. For example, if the line cut the circle, pole of this line is P, that is x1 by 1. Now we have to find polar of P. Polar of P is S1 equal to 0, that is xx1 plus y by 1 minus r square equal to 0. Now compare these two, because this line is polar of P x1 by 1. Actually, polar of P x1 by 1 is this. Compare these two. 1 and 2 are identical. So, x1 by L equal to y1 by M equal to minus r square by N. From this equation, x1 by 1 equal to minus r square L by N minus r square M by N. Here, the circle center is origin, radius is r. If the center is not origin, how to find pole of a line? In general, if the circle is x square plus y square plus 2gx plus 2fy plus c equal to 0 and the line is Lx plus My plus N equal to 0, how to find the pole of that line with respect to that circle? Now we discuss that. Find the pole of the line Lx plus My plus N equal to 0 with respect to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 is minus g minus r square L by N minus f minus r square M by N, x coordinate, y coordinate. Minus g minus f is center of the circle, r is radius, that is root of g square plus f square minus c, from that r square equal to this. N equal to, in this line, this is the line L, this is the line L. In this line, you have to substitute the center. Instead of x and y, center of the circle is minus g minus f. Just we have to substitute minus g in place of x and minus f in place of y. We get minus lg minus mf plus n. That is capital N. So, if the circle center is not origin, take the center C minus g minus f and radius r. Now, pole is minus g minus r square L by N minus f minus r square M by N. N is capital N. The capital N value is, just we have to substitute minus g minus f in the line. Center in the line, minus Lg minus Mf plus N. How to derive this one? Simple. Before, we prove that if the center of the circle is origin, minus r square L by N minus r square F by M. The same way, now origin shifted to the point center of this circle. Automatically, center becomes 0. Then x square plus y square equal to r square. The same method you have to apply. We get pole. After that, find the new point using here change of xx concept. Then we get this. In the problems, we can easily apply this formula. We get the pole of the line with respect to the given circle in a short way. Conjugate points ax1 by 1 and bx2 by 2 are 2 points. These two are conjugate if the polar of A passing through B, then we say that A and B are conjugate points. If the polar of A passing through B, automatically polar of B passing through A. If we draw the polar of B, definitely that passing through A. A is a fixed point. The conjugate point of A are infinite. Conjugate point of A are infinite points. Infinite points are there. All these infinite points form a line. That line is called polar of A. If you take any other point on the line, definitely that is conjugate with A. So that's why the conjugate points of A are infinite. A and B are conjugate points. The condition that the points A and B are conjugate is S12 equal to 0. That is x1 x2 plus y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c equal to 0. Sometimes circle is given, A one point is given, B another point, one coordinate means these two are conjugate points. How to find the point K? How to find the point B? Then first of all you have to find the polar of A and substitute B in that polar, we get the constant K. Conjugate lines L1 equal to L1x plus M1y plus M1 equal to 0. L2 equal to L2x plus M2y plus M2 equal to 0. Are two lines. These two are conjugate lines. What is the condition? We have to discuss here. What is the definition of conjugate lines? If the pole of one line passing through another line, then the lines are said to be conjugate lines. This is L1, pole of this is L1, pole of this is P lion L2 equal to 0. Pole of L1, lion L2, then L1 and L2 are said to be conjugate lines. If the pole of L1 lion L2, automatically pole of L2 lion L1 must, that is Q. Now L1 and L2 are two lines. What is the condition? These two lines are conjugate. L1 L2. Pole of L1 is minus r square L1 by N1 minus r square M1 by N1. That we substitute in this line, we get this condition. Minus r square L1 L2 plus M1 M2 equal to N1 N2. Now, if the circle is x square plus y square plus 2gx plus 2f5 plus c equal to 0, what is the condition? Two lines are conjugate. L1x plus M1y plus M1 equal to 0 and L2x plus M2y plus M2 equal to 0 is r square into L1 L2 plus M1 M2 equal to, just we have to substitute the center of the circle minus g minus f in L1 into in L2 y2. L1 of minus g minus f, that means just we have to substitute this one. That is nothing but minus Lg minus Mf L1g M1f plus N1 into minus L2g minus M2f plus N2. So we can easily get the value of K. Sometimes two lines are given. One line contains constant K. How to find the constant K? If these two lines are conjugate, we can easily get the value of K by applying this formula. R square, R is the radius of the circle. Root of g square plus f square minus c, that is R. Inverse points. Let S equal to 0 be a circle and C be the center of the circle. P and Q are said to be inverse points if P, Q and C are collinear. P and Q are same side to C, either right or left, whatever it may be. That is one condition. Second condition is CP into CQ equal to R square. CPQ collinear and same side to the C. Second condition is CP into CQ equal to R square. Then we say that P and Q are inverse points with respect to the circle. R is radius of that circle. How to find inverse point of a given point? P is the given point. How to find the inverse point? Simple. First we have to find the polar of P that cuts CP. That point of intersection of polar of P and the line joining C and the given point CP. The point of intersection of these two is called inverse point of P. Q is foot of perpendicular of P on the polar of P. Q is foot of perpendicular of C on the polar of P. P is outside, inverse point is inside. If P is inside, inverse point is outside. These are the properties of inverse points. Now, the last point is length of the chord having Px1y1 as midpoint, that is 2 root 2 mod x11. P is midpoint. P is a point inside the circle Px1y1. Length of the chord having midpoint Px1y1 is 2 root 2 mod s11. So we can easily prove that center is this chord P, given point CP, we can find the distance, radius we can find R minus R square minus CP square 2 root R square minus CP square 2 root. We get length of the chord, simply we get 2 root mod s11. R square minus CP square is s11. But here P is inside point. That's why modulus necessary 2 root mod s11. It is the proof of that. Simply we can prove that. Okay. Thank you, my dear students.